Okay, finally we're going to look at 3 examples where we are going to verify an identity, and we're going to use some of our new half-angle identities in order to accomplish this. So here I have this equation, and I want to verify that it is in fact an identity. Remember that we always want to try to start, on the more difficult side and turn it into the simple side. So this is kind of obvious that the more difficult side is over here on the left of the equal sign. Looking at this, I have 2 terms. I notice that on this second term here I have a half angle, and I generally like to deal in whole angles, or in other words we kind of try to turn our terms into expressions that have a whole angle as opposed to a half angle or a double angle. So having said that, if I am looking at my half angle identities for tangent, and we're going to scroll up here and look at those together. So if I'm looking up here and I have my half angle identities for tangent, I have 3 choices for possible solutions, or I have 3 choices I can use. Now, because the other term in my identity has a denominator of 1 plus cosine A, I get the choice of using either of these 2 as opposed to maybe the third option for tangent. I'm going to go with this first choice here, where I actually have a square root symbol, 1 minus cosine A, 1 plus cosine A, and we're going to see what we can do with that form of our identity. So moving back down to my problem again. If I were to replace this portion right here with the half angle identity for cosine, the half angle identity for tangent, which looks like 1 minus cosine x all over 1 plus cosine x. I am taking the square root of it, but because this tangent is squared, I will actually be squaring that. And then we're just going to rewrite this other term 2 over 1 plus cosine x minus what we just rewrote here. So simplifying that, if I square something that has a radical, then this portion just comes out, right? So I have 2 over 1 plus cosine x minus the second term, which is 1 minus cosine x divided by 1 plus cosine x. So I have common denominators between these 2 fractions, and therefore I can write them as a single fraction with the numerator combined. Now I want to caution you here. I wrote this numerator here surrounded by parentheses, and I did it for a reason. Because of this subtraction sign here, students tend to make the mistake of just bringing down the 1 minus cosine x and not remembering that I'm eventually going to be distributing that negative sign to both of the terms in here. And if we don't surround that with parentheses, students tend to forget distributing it to the second term. So I'm going to rewrite this now as a single fraction, combining my numerator, and that would look like 2 minus 1, and then we multiply that, a negative times a negative cosine to give me positive cosine x in the numerator over the single denominator of 1 plus cosine x. Now we're just going to combine like terms up here, and I see 2 minus 1 is 1 plus cosine x divided by 1 plus cosine x, and those are the same terms. So this just cancels out, and I get 1 equal to 1. So I just showed then that I can indeed turn the left-hand side into the right-hand side. I challenge you, because it should work out the same, to maybe go back, and although we chose this form of our half angle identity for tangent with the denominator looking like this, I believe that you could have tried it with the other form of our tan half angle identity as well. So let's look at this example then. Again, we're still trying to verify that this is an identity. I have on the left hand side over here sine squared of x over 2 equal to the right side over here. Now, I'm going to go ahead and I'm going to work dealing with the right-hand side to begin with. And what I initially think I want to do, since I don't exactly know where to start, maybe right off the bat, this is what my process would be. I'm thinking that I'm going to take these terms right here that are tangent, and I'm going to rewrite them in terms of sine and cosine. So I want this entire right-hand side over here to be written in terms of sine and cosine. So tan x turns into sine x over cosine x minus the sine x that was up there, divided by 2 sine x cosine x for the denominator. Now, because I have complex fractions going on here, I'm going to multiply through by a common denominator to get rid of cosine x. So if this is a denominator and this is also a denominator, the common denominator would therefore be cosine x. So if I multiply the numerator and the denominator by cosine x over cosine x, this turns into sine x minus sine x times cosine x, just using the distributive property, divided by 2, and these cosines cancel in the denominator, leaving me with just sine x. Now if I have this right here, the next thing I would do is recognize that I have two sines, or I can factor a sine x out of both of these terms here. So we're going to go ahead and we're going to factor a sine x out, and we have sine x times 1 minus cosine x divided by 2 sine x. Now that I've done that, I have a common factor of sine x occurring in the numerator and the denominator, so we're going to cancel them, and the farthest I can take the right hand side over here is so that it looks like 1 minus cosine x divided by 2. So if you stop right here and you don't know where to go back to what we're trying to turn this into. So I'm going to go back up here to the top. I recognize that this, although this term is, although sine is squared, it's still a half angle identity. The half angle identity for sine looks like 1 minus, we'll do this, 1 minus the cosine of x divided by 2, all under a radical. And just so that I can remind you, that's pretty close to what we have on the right hand side. Since this sign is squared, we need to account for that. And when I square something that's under the radical, we simply take out what's underneath. So I would be left with 1 minus the cosine of x, 1 minus the cosine of x over 2, which is what I turned the right-hand side into. And since I turned both sides, independent of each other, into the same expression, I have shown that this is an identity. Okay, the last one we're going to look at together in this video is another identity that I want to be able to prove. This one looks like secant squared of x over 2 is equal to 2 over 1 plus cosine x. Now the right hand side over here is pretty simplified. I don't really know if I can do a whole lot with it. Since the left hand side is addressing a half angle anyway, go back and let's look at my half angle identities. When you look at the half angle identities, you notice that they have cosine x added to a 1 or subtracted from a 1. We have a 2 in there, so this is kind of looking like a half angle identity. So I think I'm going to start on the left hand side. I know that although I don't have a half angle identity for secant, I do have a half angle identity for cosine, and cosine and secant are reciprocals of each other. So I'm going to rewrite the left hand side over here using the reciprocal identity, which looks like 1 over the cosine of my angle x over 2, and it's cosine squared of x over 2. Now I can rewrite the denominator using the half angle identity, which says 1 over, remember the half angle identity for cosine is 1 plus the cosine of x divided by 2, but we have to square it, which is good because it's going to get rid of our radical for us. That leaves me with 1 over 1 plus the cosine of x divided by 2. And when I simplify that, this 2 simply moves up here to the top, and I'm left with 2 over 1 plus the cosine of x, which is what I was trying to show, 2 over 1 plus the cosine of x. So I just showed that they are identities. I verified that they were identities.